All right, first one's easy. Evaluate this function at x equals 3. So you are simply taking 3 and plugging it in place of x. All right, that's going to give us 4 minus 2 times x squared. So that's going to be 3 squared. All right, so we have the 4. 3 squared, or 3 times 3 is 9. 2 times 9 is 18. And 4 minus 18 is negative 14. So that is answer A. All right, number 2, we have the piecewise function, f of negative 1. That means we're plugging in x equals negative 1. Okay, this column here is the y values, and this column here is the x values. So since x equals negative 1, we need to use this one right here, because negative 1 is less than 0. So the y value, or the output, is 5. So that is answer B. Okay, you can't plug the negative 1 in this one, because this is for x is greater than or equal to 0. So this one does not apply. It's just 5. All right, number 3, evaluate f of u squared plus v for f of x equals this function here. All right, so we're just taking this expression, u squared plus v, and we're plugging it in place of x. All right, so that's going to equal 4 times x, but x equals u squared plus v. And then we have plus 6. Distributing 4 times u squared. 4 times positive v plus 6. There are no like terms, so that's it. Answer D. Number 4, what is the domain for f of x equals radical x squared plus 1? Okay, anything under the square root has to be greater than or equal to 0. Otherwise, you're going into imaginary numbers. So x squared plus 1 has to be greater than or equal to 0. Okay, I just took that expression inside the square root. And I can see already anything will work for x, because x squared is always positive, or 0. Okay, this is going to be positive or 0. And if you do plus 1 to something that's positive or 0, that's also going to be positive. So this right here is always true, as long as you don't use imaginary numbers. So the answer is all real numbers. Okay, the entire number line works. The entire number line works. So that runs from negative infinity all the way to positive infinity. The whole thing. All right, the way you write that in interval notation, negative infinity, comma, infinity, and you use the curved parentheses because infinity is not a real number. And it's not an actual number. So that's it right there. Answer A. All right, number 5. Here we're doing Newton's quotient. Okay. The author uses f of a plus h. We did it as x plus h, but it's the same thing. Now, you could do this whole thing in one shot, but I think it's better to evaluate this part first, f of a plus h. So I'm going to do that first. All right, so f of a plus h, that means you are subbing in a plus h wherever you see an x. So that goes into the x squared. All right, so f of a plus h is going to be a plus h squared plus 3. All right, and you can write this twice if you want. I am just using FOIL, a plus h times a plus h, because it's squared. So when you do the first, a times a is going to be a squared. Inner is going to be h times a. Outer is going to be h times a. So that's going to be 2h times a. All right, that's for the inner, outer. And last is going to be h times h, so that's h squared. And we still have plus 3. All right. And now we're going to do this part here. And then we're going to do this part here, minus f of a. Well, what do we do for minus f of a? That is easy. I'll do it in a different color. All you have to do is take a and plug it in for x. So that's your f of a part. So it's going to be minus f of a. It's going to be minus this whole thing. I'm plugging in a, so that's going to be a squared plus 3. All right. So this part here is my f of a. This part here was my f of a plus h. And finally, the last step is to divide the whole thing by h. In fact, before I divide by h, let me finish this here. Let's distribute the negative. Minus a squared, put it underneath the like term. Minus a squared. And then minus positive 3, put it under the like term. All right, and what happens? A squareds cancel. 3 minus 3 cancels. Bring down your 2ha. And bring down your positive h squared. The last step is to divide by h. All right, and when I divide by h, each of these terms over the common denominator is divided by h. So h over h cancels, and we're left with 2a. H squared divided by h is just h. So that's just 2a plus h. And that is your final answer. And that looks like answer C. All right, so that's it. Number 6, what is the domain for f of x is radical x minus 5? Remember, the domain is the potential x values. Remember, the square root has to be greater than, the thing under the square root has to be greater than or equal to 0. So this expression, x minus 5, is greater than or equal to 0. All right, solving, just do plus 5 on both sides. And x is greater than or equal to 5. On the number line, you start at 5, you include the 5, and then it's everything greater than or equal to 5. All right, so this here, if you did it in interval notation, it starts at 5, it includes 5, so use the square bracket. If you use the rounded one, that means it doesn't include 5, but see, it's greater than or equal to 5. And this runs all the way to infinity. So it's 5 comma infinity. And for infinity, you always use the curved parenthesis. So that's your answer right there. And that is answer B. All right, pretty simple. All right, number 7, what's the domain for 1 over x squared minus 9? Pretty simple. Okay, the only thing here you have to make, there's no radical symbol, so this denominator cannot equal 0. It can be negative, a denominator can be negative, but it cannot equal 0. So x squared minus 9 equals 0. We're going to find out where x equals 0, and we will exclude those values for x. All right, solving for x squared, we do plus 9 on both sides. 9 minus 9 cancels, bring down the x squared, and x squared equals 0 plus 9. Solving for x, the opposite of squaring something is to take the square root of both sides. Now, square root of x squared is x, And remember, when you do square root of both sides, you have to do plus minus. So it's both positive 3 and negative 3. And why is that? Because if you put a negative 3 here and square it, it's going to be positive 9. So both plus and minus 3 works. Now we said the denominator cannot be 0. We set this equal to 0. So we know that x cannot equal 3 or negative 3. All right, those are the numbers that make the denominator 0. So on a number line, you have the negative 3. Remember, the smaller numbers are on the left. You have the positive 3. All right, and the answers are everything in between. It excludes the 3. Negative 3, it excludes positive 3, but it includes everything that goes to negative infinity, everything in between, and everything that goes to positive infinity. All right, so for interval notation, it starts at negative infinity, and you use the rounded parenthesis, and it goes to negative 3. It does not include it, so use the rounded parenthesis, in union with everything from negative 3 to positive 3. Use the rounded because it doesn't include negative 3. It doesn't include positive 3. Use the rounded parenthesis. In union with 3, once again, use the rounded, and it goes all the way to positive infinity. For infinity, always use the rounded one. So that mess right there is your answer. And let's see, negative infinity to negative 3, negative 3 to 3, and 3 to infinity, all rounded parentheses. So that is answer D. All right, number 9, what is the domain for this function here? Now the numerator, this could be anything. All right, this is just x minus 5. You can plug in anything for x right there. The denominator, we said under the square root has to be greater than or equal to 0 for a radical, but it's in the denominator, so it also cannot be 0. So this right here has to be greater than 0. It cannot equal 0 because it's in the denominator. All right, so x minus 4 has to be greater than 0. Simple. And if you do plus 4 on both sides, it cancels, and x is greater than 4. That's your only restriction. The numerator's okay. This is your only restriction. So x is greater than 4. You start at 4, and it does not include 4. It doesn't equal 4. And it's everything greater than 4. So it runs to infinity. So it doesn't include 4. Use the rounded parenthesis, and it runs all the way to infinity. And for infinity, use the rounded parenthesis. All right, so that is answer D. All right, last one, number 10. What is the domain for this function here? So the numerator is underneath the radical. So this right here, underneath the radical, has to be greater than or equal to 0. All right, x minus 4 is greater than or equal to 0. And if we add 4 to both sides, 4 minus 4 cancels. Bring down your x, greater than or equal to, and 0 plus 4 is just 4. All right, so that's out of the way. And the denominator, the only restriction is that that cannot equal 0. All right, x minus 5 equals 0. You add 5 to both sides, and x equals 5. All right, we said the denominator cannot equal 0, so wherever x equals 0, that's what x cannot equal. All right, so it can't equal 5, and it has to be greater than or equal to 4. What does that look like? Well, let's put a 4 and a 5 on the number line. All right, smaller numbers are to the left. And let's see. Does it include 4? Yes, it equals 4. Does it include 5? No, 5 is not included. And it's everything greater than 4. So this way, and this way right here. And this is infinity. All right, so since it includes 4, use the square bracket because it includes 4, and that runs to 5, but it does not include 5. Use the rounded one, and that's in union with 5. Once again, rounded parenthesis, it doesn't include 5, and it runs to infinity. For infinity, use the rounded one. All right. So 4 and 5, we got that right here. And 5 to infinity, we have that right there. So that is answer A.